Okay, can everybody hear me? Cool. Can everybody see my screen? It should be a blue slide. Awesome. All right, guys, so I'm going to try to look this way at you guys and go through my slide. So I'm excited to give you this presentation today, especially since today Bitcoin hit over $10,000 a coin while we were in class. And I'm sure you're inundated with questions from relatives about how the blockchain works and what this technology is about. In my opinion, the underlying technology is the real game changer here, not really the currency aspects of all these different crypto coins. So I'm going to give a very cursory introduction to some of the technology, some of the terms, and then I'm going to, the second part will be a high-level case study of a company that's actually using this technology to innovate in their industry. And then at the end, we'll open it up to some questions if you guys don't mind. Is that okay with everybody? Thumbs up? Awesome. All right. So first, let me introduce myself. I know you've seen me on the Slack channels, but we don't really get a chance to get to know each other, which is why these brown bags are awesome. So my undergrad was in a non-STEM field. During college, I started my first businesses. I grew them to over 33 different retail businesses in upstate New York, Western PA, Ohio, down to even Kentucky. Got out of retail, got into the non-emergency medical transportation business, and within a year grew to Ohio's largest provider for that business by creating a new business model. And we can talk about that another day, maybe another brown bag. It was a pretty interesting business. Sold it off and didn't know what I wanted to do. Knew I didn't want to do retail anymore, so I got into tech and I became a non-technical founder, and I created Loyal Loops, which is a loyalty platform that integrates with different point-of-sale systems. This year, I launched a separate company, still small, called Buzzy, which does location-based marketing using Bluetooth beacons. Okay. So as most of you know, I'm currently a student in CS5 at Lambda School with the majority of you guys. Personal, that was my professional and my education. Personal, my 3-year-old niece ranks me 3 out of 3 for her favorite uncles. I think the vote was rigged, but whatever. And I love the blockchain-based technologies, and I'm hoping to make a career out of decentralized technologies. Anything from working with IPFS or some of these dApps that are riding the chain now. Okay. So first, we're going to cover the key terms. First one that we need to understand is the block, right? So a block, it's very simple. It's a group of transactions, okay? I gave 2 examples of the 2 most popular blockchains right now and how they're limited, the block sizes. The Bitcoin blocks are limited to 1 meg per block. Okay, Ethereum does something different, where their blocks are limited by their gas limits. Gas, and I'll explain this in a slide up ahead, gas is basically the transaction fee paid to the miner to add that transaction to the block. So they basically put a price limit of how much per block can be spent to handle those transactions, where Bitcoin does it by data size. All right, so blockchain, right? A bunch of blocks makes up a blockchain. So what is a blockchain? At its simplest, a blockchain is a distributed ledger. So it maintains from the genesis block, from the initiating block, all the way through all the transactions lumped up by blocks. We covered data structures the other day, and a good way to think of the blockchain is like a linked list, where you just keep adding to the end. So there's 2 types of blockchains. There's the public blockchain, like Ethereum or Bitcoin, where anybody can add to the block. And then there's private blockchains, where a specific group of people, companies, etc., are the only ones allowed to add to a block. And a lot of the innovation you find today is on private blockchains. So you have companies such as Chase, I believe theirs is called Quorum. You have IBM has their own, Microsoft has their own, where they're putting out iterations of the blockchain for corporate use where they're private, so that a business such as MadHive, the company I'm going to cover in this talk, sets up a private one that only specific actors can deal with. Okay. So this is a visual representation of the blockchain. The gray to the left, the gray bricks to the left would be like the transactions. The blue boxes would be the blocks, and then they're all tied in together, if that makes any sense. All right. Distributed ledger. We said the blockchain is a distributed ledger. So what's a distributed ledger? So it's a ledger of any transactions or contracts maintained in a decentralized form across different locations called nodes. So if you've ever run any type of mining software or anything else on your computer trying to play around with the blockchain, you end up with a copy of the chain. Now you're part of that distributed ledger. You're now a node on that distributed ledger. It eliminates the need for a central authority to maintain the database, the ledger. Okay, and each node that's connected to the network can access the data, right? They all have identical copies. So here's a little bit of a picture showing you on the left. It shows you what a centralized network looks like. That's where if you had something like a SQL database or even a NoSQL database, right? Like Mongo or whatever, you'd have a centralized database where your data is all stored in one location and the nodes all access it from there. In a decentralized one, you see that there's different hubs with other nodes spoking off. Okay, and then if you look at the red and the blue, those are your public and your private blockchains. They look very similar because they are, except one limits who can interact with it. Okay, gas. We spoke a little about this when we spoke about the block size for Ethereum, right? So it's a special unit used in the Ethereum blockchain. It's not used in the Bitcoin one or any of the other models. Well, you know, they call them different things, but it's basically a transaction fee, right? It's important because it ensures that the network is not calculating and adding transactions to the block and to the chain, right, that aren't valuable. So someone doesn't flood the blockchain with a bunch of unnecessary transactions. Okay, they have to pay to get it recorded. Okay. So I mentioned nodes, I mentioned miners. I just want to make sure you guys get those clear in your heads. So a node downloads every block and transaction. It also does some checking to make sure those transactions are valid. It basically is the way that we're able to operate a trustless system where you don't have to rely on anybody else's word that the data is correct. A miner is a node, right? And it adds and it creates the blocks and adds the blocks to the blockchain. A node doesn't have to be a miner, but a miner has to be a node. All right. So there's a couple concepts you're going to hear about when you're listening to people talk about the blockchain. Proof of work and proof of stake. So we're going to cover those a little bit now. So proof of work is what miners do, right? They basically, other than adding up all the transactions, they have this puzzle and they have to solve the puzzle, okay? Before they're allowed to add a block to the chain. When a miner finds the correct solution, he announces it to the whole network. For that, if it's accepted by the other miners and the other nodes, he receives a monetary reward, he or she, right? So in these mining pools, the coins that are generated as their reward are what they're going for, right? That's why they're mining. That's proof of work, right? So they have to do this complex calculation. Right now, I believe on Ethereum, it takes 14 or 15 seconds. I may be wrong. But it takes some time. And I think on Bitcoin, and you guys can correct me if I'm wrong, I think it's a little over 10 minutes at this point, correct? I'm not sure. That might be completely wrong. I have too many numbers going on in my head right now. So forgive me if it's wrong. So let's go to proof of stake. So with proof of stake, in my opinion, it's a better way to validate transactions. Okay. Ethereum's actually migrating from a proof of work basis over to proof of stake. So the creator of new block is chosen in a deterministic way depending on his or her stake. Okay. So basically, if you own 1% of that cryptocurrency, say Ethereum, for example, once they switch to this, right, you can mine 1% of the transactions. Okay. So if you don't have a stake in the chain, if you're not already holding those coins, right, you're not going to be able to mine. The miners don't earn a reward for solving a puzzle. They earn the transaction fee, those gas units that I talked to you guys about. So why is proof of stake better than proof of work? So one of the biggest problems with proof of work is what they refer to as the tragedy of the commons problem. Basically what it's saying is that in the future, when there's less coins left to mine, because remember, there's a finite number of coins available to be mined, okay? More miners will move away to either mine other stuff or do something else with their computing power. As there's less miners, there'll be less people using the network. The fees that are paid by people to handle transactions will be less. The network becomes vulnerable to a 51% attack. So part of the blockchain is once, we said that once you build a block of transactions and you add it to the chain, okay, you then have everybody else validate that and agree that that's now part of the chain. Well, what happens if an unscrupulous actor has control of 51% of the network? Now they can change transactions, okay? And they can, because of their overwhelming computing power on that network, if they have 51%, right, they can validate those and it can wreak havoc to the network. So that's what they can do. They can create fake blocks, basically fraudulent ones, with different stuff and invalidate stuff. So it won't work at that point. The blockchain is susceptible to fraud at that point. So everybody right now is trying to work on problems in this industry to help avoid that. Okay. So smart contracts, right? This is the main thing I want to talk to you guys about because I think they're awesome. And I think it's something that everybody, everybody should take a look at, especially here at Lambda, right? It's a growth area, and I think you should familiarize yourself with it. It's very similar to JavaScript, the native language that it's written in, and I'll go over that with you. But so what's a smart contract, guys? So basically, this is Vitaly's definition. Is a smart contract is a mechanism involving digital assets and two or more parties, where some or all of the parties put assets in and are automatically redistributed among those parties according to a formula based on certain data that is not known at the time the contract is initiated. Basically, a smart contract is what it sounds like. It's a digital contract where all the rules, everything is stipulated into it, okay? Can think about it like, we can use real quick an example of like a bet. I could bet Moses that the Pittsburgh Steelers will beat the Miami Dolphins, okay? And the contract could be waiting to see, we each put in our money and the contract would hold that money and then issue it to whoever won the bet. That's a very simplified thing where we wouldn't have to trust each other with the money. Make sense? Thumbs up, thumbs down? Cool. All right, I don't want to get too deep into it because there's a lot more for me to go over with this subject. All right. So with the smart contract, the parties involved are known, right? It runs on the EVM, which is the Ethereum virtual machine. And there's a few languages that you can write a smart contract in. The most popular by far is called Solidity. And it's very, very similar to JavaScript. You're not going to have a problem picking it up. It'll take you a couple hours. At the end of this talk, I'm going to give you some awesome learning resources, including some tutorials that are not free. The ones I'm going to point you to, there's free and not free, but the one that is not free that I'm going to point you to is by far the best. I've done like 10 of them. It is by far the best that I've come across. All right, so what's a DApp? You might have heard of DApps. Has anybody heard of DApps? Show of hands. Sort of? Okay. A DApp is a decentralized application, right? So backend code runs on the decentralized network, okay? So that would be on the chain, guys. So traditional apps, they run on servers. These apps run on the blockchain. So you put your code on the blockchain, okay? It can have front-end code so that you can interact with it from like a website, but it doesn't have to. What does and doesn't constitute a DApp is really contentious online. I mean, I found myself diving into flame wars with people that I haven't seen since Emacs versus Vim, right? But basically, just consider it a decentralized app as an app that runs on the blockchain. Solidity, that's the language you write the smart contracts in. And guys, if I didn't mention it, a smart contract is a form of DApp. It's not the only one. You guys might be familiar with some. Like, for example, if anybody's ever downloaded anything off BitTorrent, BitTorrent is considered a DApp. Okay, so Solidity. Solidity is contract-oriented. It's made for the smart contracts. That's why it was created, right? It's a high-level language for implementing the smart contracts. You'll see a little bit of C++ in there, a little bit of Python thrown in, and some JavaScript. I'm telling you, if you guys know JavaScript, you'll know Solidity. You'll pick it up in no time. Statically typed. It supports inheritance, bringing in libraries, and user-defined types. I come from a Java background, and I love types, and I wish I could just type everything, right? So it's the most widely used language, and like I said, it'll take you an afternoon to pick up. You might hear people talk about MetaMask. Now, MetaMask is pretty cool. MetaMask is a free tool. You can use it. It's a browser plugin. It goes on Firefox or Chrome. And it's a bridge that lets you run the dApps right in your browser without a full Ethereum node, right? Usually, if you're running a dApp, you have to be running a node so that you can access the blockchain. But with MetaMask, you don't have to download the blockchain or run Geth or any of the other stuff to run your node. You can just open up a browser, fire up MetaMask, and you can access the dApp. I mentioned Geth a second ago. So Geth is the Go Ethereum client. It's all from the command line. It's open source. It's available, but it's written in Go. Geth can be used to mine Ether. Geth can be used to manipulate the blockchain by sending funds back and forth to different addresses. You can create contracts, and you can explore the block history. It's like basically the Swiss Army knife of the Ethereum chain. You just use Geth. You can create your own coin. Fire up Geth, follow a 1-hour tutorial, and you can start your own cryptocurrency. I did it in one night while I was eating dinner with the laptop on the table. It's an amazing tool. Web3.js is a JavaScript library for Ethereum. So when it gives you a library to import so that you can access the blockchain, like if you want to put a front end to your dApp. Okay, guys, that was, oh man, I'm running out of time, so I'm gonna make it quicker. All right, so we got 8 minutes, guys, so we're gonna do this. We talked about the smart contracts and the key terms. Now I want to introduce you guys to MadHive. I've been following MadHive since about the beginning of the year. I think they're amazing. So what they've done in consortium with a lot of the ad industry is create these tools and create this auditing to make it, well, I'll show you. Okay, so what's MadHive do, right? MadHive provides a unified video ad platform with a real-time AI powered by the blockchain. It utilizes a private blockchain, so there's only certain actors that can interact with this, right? It builds innovative products for streaming, web, mobile, and to capture first-party data. First-party data would be like you and me when we're watching a Hulu video or a something on Netflix. Okay, well, Netflix doesn't have ads, but any streaming service with ads. Okay, and it connects the different audience members to their different devices. So a lot of times when advertisers, when these publishers of content, they don't want to give up the information on their users to the advertisers, even though they're charging the advertisers to access them. MadHive helps break down those walled gardens between these different advertisers, between these different publishers, so that the advertisers have a more robust view of their customers and who they're really targeting. So what problems are they solving? Well, one of the biggest problems in the ad industry is fraud, and this helps eliminate fraud by providing transparency, saving the industry as a whole billions of dollars due to discrepancies between parties. Because we talked about those walled gardens a little bit ago, they aggregate the data of the brands so that it's better for market segmentation. The advertisers can actually target exactly who they want. The result is that the advertisers no longer need to worry about dealing with a third party that usually gives them these metrics, separate from the publisher, which in turn causes impression prices to be more valuable because you can target better. So the advertisers get to target better. They save money by not having to pay for additional services from metric providers. And the publishers of the content get to charge more because now they can give better data. You can actually target who you want, right? Instead of like a shotgun approach. So I wanted to show you guys this because I thought this was pretty interesting. At the bottom of the slide, you'll see where it shows you a breakdown of how advertising money gets funneled off. For every dollar that's paid in advertising, 40 cents makes it to the publisher. From the buy-side ad server all the way to the sell-side ad server, those are all middlemen and services that suck up the difference. They make more than the publisher. Since we got 5 minutes, I'm going to speed through a little bit. Forgive me, guys. All right. I want to talk to you guys about fraud because that's one of the biggest benefits. MethBot, I don't know if you guys are familiar with or not, but MethBot was the largest fraud, bot-based fraud in the advertising industry that's been discovered in the past several years. There's other ones that are close to its size, but it was the biggest by far. The fraudsters spent millions of dollars developing MethBot. Basically what MethBot did was created a bunch of fake sites that didn't really display the ads and then had fake users, fake bots going in and the program basically algorithmically defrauded the advertisers out of their money with clicks and impressions that they thought were coming from different IPs, from different people, but they weren't. It was all just fraud. There was no users, nothing. They estimate that it was from $2.6 to $5.2 million a day in fraud generated from MethBot. And by the way, guys, MethBot is still around. They can't stop it. They block the addresses they can, but the software is still out there. The people are still making millions of dollars off of it and other fraud ones. And so with MadHive's tools and with everything being transparent on the chain and the analytics that they provide, it kills fraudsters like MethBot's opportunities to defraud the advertisers. Okay, so with MadHive, there's 4 terms that I need to talk to you guys about. One is the Mad Network, which is a legally separate entity from MadHive, run by an ad consortium. It's basically the decentralized network for the ad industry. It's the blockchain that the ad industry is going to be using. Okay. And different dApps are being rolled out on that blockchain. Oh, sorry, I keep hitting the button. So it's modeled upon the Ethereum blockchain for its architecture. Now let's talk about Mad Token, Mad Cred, and Mad Bonus. 3 minutes left. Okay, Mad Token. That's the native token for the Mad Network. Okay, that's like the Ethereum or the Bitcoin of that network. Okay, it can be converted and traded to fiat currency. So this will be the coin when it launches. I think it launches in like a week. Okay, this will be the coin that is going to be traded on the different exchanges. Okay, MadCred. MadCred is a token issued by the smart contract. The smart contract creates MadCred, right? And it's temporary and it's non-convertible. You can't trade that on the exchanges. It's just for use in the network. And I'll explain what they do. And then there's Mad Bonus. Mad Bonus is another token issued by the contract to the ad firm that represents the advertiser. This token isn't convertible. It can't be traded on the markets, and it can be used to stake contracts in lieu of Mad tokens. When you create a smart contract, you have to stake it with some money. So either use Mad tokens or the Mad Bonus. So let's go through the quick steps. I believe there's 4 of them. Okay, so what does MadHive, how does it work with their smart contract? A business wants to advertise and goes to their ad firm who puts together $1 million ad campaign. Cool. The ad firm procures $1 million worth of Mad token. So if they don't have them, they have to go to the exchange and buy the $1 million worth of Mad token. They then set up their smart contract using MadHive's tools and put that smart contract holding that $1 million worth of Mad token in collateral, okay? The publishers display the ads. As they display the ads, they're issued by the smart contract MadCred. The ad firm pays the publisher for the ads run on the site. Once the publisher's paid for all the ads in real cash, the MadCred are released by the publisher back to the contract. The contract then destroys those MadCred. They disappear. So the last step is the smart contract destroys the MadCred. The Mad tokens that the smart contract was holding go back to the agency, to the ad firm. And then the last thing the smart contract does before it dies is it creates Mad Bonus tokens. Mad Bonus tokens were thought up for a couple reasons. One of them being as an incentive to ad firms to use this network, right? And what they are is basically like a bonus. So they're awarded to the ad firm. The ad firm can use those Mad Bonus tokens that are given to stake the next contract. Okay, and they have certain rules, like I think 30% has to still be made out of Mad token, but you can use Mad Bonus for the other 70%. And that's it. In the slideshow, and I'm going to post a link to these slides in our Slack channel. That's the link to the white paper if you want to learn more about them. That was a very high-level thing, and I'm sorry, guys, I've gone a minute over. There's some learning resources. The one I want to tell you about if you guys really want to learn other than ethereum.org is go to that zastrin.com. Amazing tutorials. The first one's free, and then they have 2 more advanced ones that are paid. Oh, also look on meetup.com and find yourself some blockchain groups if you want to learn more. I've gone to some amazing talks. I've met some people from the Ethereum Foundation. They're worthwhile. They definitely are. Okay, last thing I want to show you guys, and this is way out of date now that the coins have skyrocketed so much, but I want to show you why it's important you guys learn about this technology and explore this field for employment when you finish at Lambda. If you look at the end of Q2 of this year, VCs had invested $235 million into startups. ICOs had generated almost $800 million worth of investment for startups. So the funding is like night and day, the difference between funding channels coming in between traditional VCs and ICOs. Guys, that's it. Thank you for being patient with me and letting me steal a couple minutes out of your off time. Thanks for letting me present. If you have any questions, please let me know. I'll pull up the Slack channel now so I can see. And if not, and you guys have to run, thank you. I appreciate it.